Okay, next one. In molecular shape and polarity, you will be learning about to explain the VSEPR and draw the basic molecular shape and also explain the polarity and dipole moment. Okay, let's see what is VSEPR. So this one involving covalent bond only. Okay, in covalent bond or in covalent molecule, there are theory that we call as VSEPR. What is VSEPR? VSEPR is an abbreviation of valence shell electron pair repulsion, where valence shell electron pair repulsion state that the valence electron pair or just electron pairs only, electron pairs around central atom will repel one another. Okay. Like we know, electron has negative charge. So if you put electron close together, they will have a repulsion forces. So they will repel each other as far as possible. Okay. So bonding pair and electron pair are arranged to be as far as possible, and the resulting we can see shape of the molecule that we call as molecular geometry. Okay, let's see type of atom first. So in a molecule, there are two types of atom. Okay, one that we call as central. What is central? When the atom has more than one bond. More than one bond, meaning that not single bond, not double bond, not triple bond. It has more than one connection to other atom. Okay, so it will be surrounded then more than one atoms. Okay, so let's say example the nitrogen here connected to 3 iodine, so meaning that it is central. Okay, for example here nitrogen is connected to 2 other atoms, so it is central. Okay, and another types of atom we call it as terminal, where the atom only connected by single connection only. Doesn't matter double bond, triple bond or single bond, but only single connection. Okay, for example here. And terminal atom stay at the edge. Okay, at the edge. Okay, so iodine only connected to nitrogen atom. So do not connect with other atom. So same thing here, same thing here. Iodine only connected to nitrogen, so only one atom connected to it, so we call it as terminal. So same thing here, oxygen, even though it has double bond, but we can say oxygen only have connection to the nitrogen, so it is terminal. So it doesn't have connection to any other atoms. Okay. Next one, type of electron. So there are there are 3 types of electron around central atoms. So one, if you see double bond, single bond or triple bond, we call it as bonding pair. Okay, the bond we call it as bonding pair electron. So one bonding pair, you have 2 electrons. Okay, so bonding pair electrons meaning that you have 2 electrons in it. Next one, lone pair electron. So lone pair electron meaning that you have 2 electrons in pair. It is not shared with other atoms. Okay, so it stay on the one atom only. So it is called as lone pair electron. Okay. Lone electron is not pair, so it is lonely, so only single electron on top of an atom, so that is lone electron. Alright, so lone pair and lone electron is different. There are rules when we use VSEPR theory, where single bond, double bond, triple bond, we just count as 1. Okay, so single bond we count as 1. Double bond we count as 1 as well. Triple bond we count as 1 as well, because we only considered sigma bond. Okay, what is sigma bond? We will go through later. Okay, so if you want to apply VSEPR, we count single, double, triple as one only. Okay, so single bond 1, double bond also counted as 1, triple bond also counted as 1. Okay, to see the repulsion, okay, there are repulsion between bond and lone pair, and they are different. Okay, so for example, take a look at the water molecule here. Okay, so water molecule here like this. So you have 2 lone pair and you have 2 bonding pair. So here lone pair, here bonding pair, bonding pair. Okay, so the repulsion strength of electron pair is differ. When you meet lone pair with lone pair, so the repulsion between them is very strong. So if I put size of the repulsion, this one would be XL. Okay, XL size. Okay, so the repulsion is very strong compared to the repulsion between lone pair and bonding pair. So between this lone pair and this bonding pair, the repulsion is strong but less than lone pair repulsion. Okay, so this is just medium. Okay, M size. And the weakest repulsion is between bond pair. So between this bond and this bond, the repulsion would be size XS. Okay, so this is the smallest repulsion. So meaning that if I want to draw the actual atom, so this is lone pair stay very far away. Okay, here, the size of the what we call that, so the repulsion is differ according to the type of repulsion. Okay, next. So this is 5 basic molecular shapes when you have more than one bond in a molecule. So if you have 2 bonding pair or 2 bond pair in a molecule, you will have linear shape. 2 bond pair. If you have 3 bond pair, it will be trigonal planar. So planar means flat. So trigonal means triangle and it is flat. So trigonal flat. And tetrahedral, if you have 4 bond pair, you will have tetrahedral shape. Okay, if you have 4 bond pair, you will have tetrahedral shape where the 4 bond is divided like this: 1 above, 1 to the side, 1 to the front, another one at the back. Okay, the next one is trigonal bipyramidal, where you have 5 bond pair or 5 electron pair, where the shape is like combination between linear and trigonal planar. So linear here and trigonal planar here. So the angle, trigonal planar here. And the last one, octahedral, when you have linear shape bond 90 degrees to each other. So you have 6 electron pair or 6 bonding pair, and all of them up, bottom, left, right, front, back. Okay, so up, bottom, right, left, back, front. Okay. So the angle of 5 basic molecular shape is like this. So linear, how you want to, the angle of 5 basic molecular shape, you measure from bond to bond. Okay, never measure from atom to atom, measure from bond to bond. Okay, you cannot measure angle from lone pair to bond, or from atom to lone pair. It must be from bond to bond. Okay, so for linear, you will have bond to bond angle 180 degree. For trigonal planar, it's just 360 degree divided by 3, so you get 120 degree. Tetrahedral, since it will occupy up, side, front, back, so the angle is quite difficult to see unless you see the actual molecule. So you can have the 3D molecule with your lecturer, see the angle there. Okay, the trigonal bipyramidal is the mixture between linear and trigonal planar. So the angle here will follow trigonal planar 120, and here, since it is straight line, so between this bond and this bond it will be 90 degree. Okay, and octahedral, saying up, bottom, right, left, front, back, so it will be 90 to each other. This is basic molecular shape without lone pair. So we have general formula here. Okay, so in general formula, we just represent central atom as A and terminal atom as B, or bonding pair as B. So if you have two bond, one central atom, so the general formula for that molecule is AB2. If you have two bond, AB2. If you have three bond, AB3. If you have four bond, AB4, and so on. Okay.